Hello, kind wit. Hello, hello. Simi's just getting started, so I don't know. Grab a cup of tea or something. I'm waiting for some people to come online before, explaining what I'm working on and actually starting doing the thing. Also, I sense that there are some incoming ads. Hello, Kateru Ryu. Hmm. I really think I want to remake this tokenizer. Count the number of lines seen. Interesting. This tokenizer counts lines. Why? I mean, okay. Hmm. One comment. Probably, probably want to start with a um. You should probably take a look at the grammar first. I just found out that you can use Firefox video pop-out to continue watching the stream while an ad is playing. Wow. Do you also have the sound? Can you hear me right now? Yeah, you can? Holy shit. Well, Twitch destroyed in shambles. Hello, Professor Logout. So on. Hello, everybody. Oh no, but you guys on YouTube are fine, sure. The fact is that ads are running right now on Twitch. So we were discussing about what's happening, interactions between different things on Twitch. Okay. Okay, so what are we working on today? So forgetting yesterday's stream, that was mostly me trying to convince myself to make some progress on something that I need to get ready. I think I have about a week to get it done, so I wanted to make some progress with my talk. Today, I'm going back to doing a quality improvement pass, like a polish pass, plus also a design pass on Ziggy, which is my data serialization language. It's an alternative to JSON. And I want to change some things in here and make it better, make it slightly less weird. I still want to make it a little bit weird, but slightly less. And so here I was experimenting with the idea of how to make unions and enums work, but I think I'm going for something closer to what Zig syntax looks like. So yeah. Hey, thank you. So how does this work? I'm having an approach where I'm working also on the tooling. So I'm not just designing the thing and making a parser for it and calling it a day. I want the tooling integration to be good right away. In any case, it's gonna be pain because we'll need to add support for these in editors and stuff. But yeah. Kind of it's fine actually that you haven't done it yet because it's really rough. I mean, I'm not making a secret. I made a nice website for it, but I'm not keeping it a secret. It's 001, that it's like super rough. So I am changing some of the syntax. You will see me do this today because I made the schema language so much better now that basically now the data language needs to improve. We're going to update the syntax highlighting, the three-seater base syntax highlighting. We're going to update the tokenizer, the parser. I kind of want to rewrite the tokenizer from scratch because I don't trust my old self to have gotten it right. And also we want to switch to the new labeled switch syntax that Zig supports, which makes more efficient tokenizers so we can do better. And I think this is going to be basically what I work on today. Ideally, once this is done, then there's a couple more parser, well, at least one more parser that needs to be worked on. We need to take a look at the language server and see how things are implemented in the language server, update them if necessary. I'm sure there are a lot of things that we now know how to do better language server wise after all the experience that I got from Super HTML. So that's mainly it. So I think that once this is in a kind of not done, but like once this pass is going to be done, this is going to be a pretty decent project. And I want to open it to contributions more because there's a lot of missing bits and pieces that can actually be contributed by other people. I just need to, how can I say, the last time that I did this, I wasn't really ready for a lot of user contributions because I didn't know exactly yet what the path should have been for certain things, but I think I now have a better idea of how to do everything. So yeah, that's basically what we're going to be working on. Okay. Let's see. Oh yeah, man, I can't go back anymore. Like I realize now that you can express in a like very succinct manner things that you just couldn't before, and I can't see myself going back anymore. Anyway, okay, what's in a Ziggy document? Well, so here's what we're doing. My plan is this. I want to temporarily take out this concept here. So we're not going to have @built-ins anymore. Maybe we will introduce them back again in the future, but I want to basically introduce proper enums and proper unions to this language. And again, I want to do that piggybacking proper Zig syntax. Also, here's another piece of, well, you know what? I'll introduce innovations in the schema language as we encounter them. So let's update this bad boy first. Let's see, what's a value? A value is a union, a struct, a map. Hello, Penguin. So a map, now I'm gonna rename these things to dicts. So this is gonna be a dict, an array, an enum, let's keep it also. Okay. I have to add it to my online playground to understand it a little bit better off the start. Is the CLI already disable-ish? No, I'm sorry, not at all. I'm about to break everything. Or rather, the CLI interface I don't think is going to change significantly. So you could say that the interface is stable. It's just that a good chunk of it is not implemented yet. And I am changing the semantics of the language a little bit. So, you know, even if that part is stable, a lot of stuff is changing. So, but stick around. I think you will get a feel for where I'm going fairly quickly. So what's a struct? A struct is a sequence of curly, comma-separated fields and a curly. And that is fine. I don't know why I have the precedence thing. Oh, it's because it's how to interpret like an empty curlies. Like if you have empty curlies, is this a struct or a map? You don't know because they have both the same identifier. So we should probably default to map though. Debatable. In any case. So this is a struct. A struct field is an optional comment followed by a dot, an identifier, an equal sign, and a value. A map is the same except that it has strings as keys and uses colon as the separator. By the way, okay, so here's one piece of information for the people watching who don't know much about Ziggy. Ziggy is a superset of JSON. So the idea of Ziggy is to add syntax to express more precisely your intent behind certain things. So for example, there's this concept of a struct versus a map. A struct they're both key value mappings, but a struct, which uses the dot field name equal sign syntax and then value, is for key value mappings where the keys are part of a schema. They are set in stone in a schema. They have semantic meaning for the thing receiving it. While a dictionary, previously map, now I'm going to naming this to dictionary. A dictionary instead uses curly braces, uses strings as keys, and uses colon as the field value separator. This thing instead is for the case where key names are not part of a fixed schema. They are up to the user to define. And you can see here in this example where this is a made up example where I'm saying, okay, there's a kind of message, and this message is a payload, and the payload is a command struct, and then it has some fields, but the last field extra is part of a fixed schema, but what you put in extra is up to you, right? It's basically, you know, you can imagine it's some kind of like schema-less bucket of metadata that you put in here. And so we use this syntax for this, and we use this syntax for everything else. Here's the thing. This is JSON. JSON is a Ziggy dictionary. That's the idea. So you can, this works already today, but this is part of the design. The idea is that you can use a Ziggy parser to parse JSON. The CLI tool will have tools for conversion from one format to another. But the idea is that you can straight up load JSON with Ziggy and it works. You load it as a untyped map. The schema language allows you to define these things, how they should look like. So here I have a schema. For example, here the idea is message, right? There's then payload, and payload contains extra. So basically, sorry, this is here I was testing other stuff, but you can see how this can also be used to, hello blur cat. This can also be this is basically a potential schema for this document. So here in extra, I'm gonna say that I want it to be a map of anything, right? Because it is a map at the outer level, but then what the values that you put in there can be potentially anything. Let's assume that that is the case. So how do you express this? Like, what is the syntax for defining this type? The old syntax for this, I think, was something like map and then square brackets, and then here you would put any. But I'm changing this, and I'm going for, I abandoned the idea. So this was based on the idea of wrapping types. So if you wanted to do a list of something, like a list of numbers, you would do like a list of ints, you would do it like this. But we don't do it this way anymore. Now, all these sigils are all prefixes, Zig style. So this would be a list of ints. And so how do you define a map? Well, oh, sorry, a dictionary, I should say. I made a new sigil for it. So a dictionary is this. So extra is basically this. It's a map of any. And this is the sigil of a map of any. And basically, this is the type of a JSON document. When you load a JSON document, it's this. Because you don't have syntax, you're not using syntax for, like, how can I say, JSON doesn't have syntax for defining structs. And so everything is a map to you. And as for the fields being any or not, I guess it depends, right? If you want to say, well, if you're loading a generic JSON, then of course it will have to be any. But we can imagine, let's say that here, this is a map, but you want to make sure that the fields are always strings. So how do you express this? Instead of any, you say bytes. I'm calling bytes the string type. I might change it to string. I'm not sure. For now, I'm going with bytes. So you could use it to gradually type the data as you switch from JSON to Ziggy. Yeah, absolutely. There's also a feature in the language server, which I think I've regressed. Well, okay, let me see if it works still. Okay, so I want to change some syntax, but look at this. I think this still works. Or rather, I will. This I think we'll have to change a little bit, but the concept will remain. So let's say that you have extra in here, right? And or actually, I think we can do it also at the top level. So you do curlies, and then you do foo bar buzz 42, right? You get the idea. I don't know, bucks. Okay, so you have this. Is dictionary not in any? Could it be just any? Yeah, you could also have just any, and then allow whatever you want at the top level. That would also be allowed. So check this out. If I put a dot in here, or I think it has to be a name. So this is not going to be a thing anymore. I will have to change how it works, but this is the idea. You were able to say, I put here a name. This causes a bunch of syntax errors because giving it a name means that this is a struct. Again, I'm dropping the concept of struct names, but this general concept will remain. So the way it's going to work is that you put in a name and then you save. And on save, the idea is that if you give a name to a map, to a dictionary, you're expressing the intent to the auto formatter that you want to turn it into a struct. And so the auto formatter switches key syntax for you. And again, this is not, the way of turning a JSON document into a Ziggy document. It's just, one tiny thing in there that can help you as part of the whole ecosystem. So, so the way you would do it, how can I say? Let's say that you have a directory full of JSON documents. How do you translate those? The way it would work is that you define a schema. Let's assume that they all fulfill a schema. So you define a Ziggy schema, and then you will use the CLI tool, and you will use a convert feature to convert from JSON to Ziggy by applying that schema. And then there will be, you know, an implementation that looks at your JSON documents, verifies that they fulfill the schema, and if they do, then they get converted. That would be your main way, I guess. But there's also this, you know, thing where you just copy paste some JSON and it works already as is, but then you want to start typing it a little bit so you can just do this kind of stuff and have the auto formatter help you. As I said, though, I'm dropping struct names, so we'll have to find a new way. Okay, so right now I'm modifying the three-seater grammar. That is what defines syntax highlighting. So let's do this. First of all, let's see. A document is an optional top document followed by a top-level struct or a value. That is correct. If it can be any of these things, this all works for me. A top-level struct is a sequence of a struct field followed by an optional comment. Interesting. Okay. A struct, we were saying, is a sequence of curly, this style of field, and then a curly. A map is the same but different style of fields. An array is curlies, then elements, some comments maybe. This comment stuff I'm not really totally sold on. Maybe I'll revisit it, but fine. An array element, a union. Okay, let's start looking into this stuff. So a union is an enum parentheses value. Yeah, but an enum is not this. An enum is this. So the syntax that I'm going for is this. Basically, let's say that you have a field that can be, you know, a command or a notification. So the way I want it to be like this. So let's say that it's the payload. And the payload can be either a command or a notification. So the syntax that I have still on the website shows you this, right? Payload is, and then struct name. And the way, this is the old way. So you had struct names, and in the schema language, you would say this. You would say payload can be a command struct or a notification struct. This was nice, but now I'm upgrading like to full-blown like generic unions where you can put everything in there. So I want the syntax to look like this. I want the syntax to be basically dot case of the union, and then within parentheses the value. And if it's a struct, then it's gonna be curlies within the parentheses. And if instead it's gonna be, you know, if the union has like a string or a number, you just put the string or a number directly there. But you can see that this shows up red because it's currently, well, not supported at all. And so this would be, I don't know, do equals dot banana, and then foo equals, I don't know, bar. Okay, so let's fix this. The LSP is going to be angry with us until we change the parser. So it's going to be a while before we get there. But let's start by making three-seater happy with us. Also, I think that like Zig, I'm going to put a dot in front of structs. So when you define a struct, you have to put a dot in front of it. That's what I'm thinking. Hey, Winston. I'm very happy to be learning more about Zig. Let's go. I have been watching mostly Lawrence and Andrew for the past few days. Oh, really? You've been binge watching. Holy cow. Well, Winston, you are in the right place. So if you want to, I don't know, if you need help, like you have questions about, you know, how to proceed, what to do next in your journey learning Zig, this is the right place to ask. I will say one thing. Actually, you know what? Since you expressed interest, I will share with you like the full answer to usually the question that I get asked about how to get started learning Zig. Maybe you don't need this, but just in case there's somebody else watching who might benefit from this. Number one is go to the Learn section on the Zig website. Look at the resources available there. You want to read the language reference because you want to know how the language works. That will tell you about the language, but not the standard library. So you also want to take a look at the documentation for the standard library. But even better, you want to learn how to read the standard library source code. So you don't want to consider the documentation the only way you can learn something about the standard library. No, the source code is at your disposal. Not all of it will be immediately easily understandable for you right away. Some of it will be a little bit too complicated, but not all of it. And in general, it's just a matter of like ramping up. You can get there. I know there are languages where the standard library is impossible to understand. This is not the case with Zig. So you can learn it and you are expected to do it. Not only you are expected, but I would say it's genuinely the shortest, the quickest way of learning things. Like, and when I say this, I mean stuff like this, like you have your LSP set up ideally. And so you say, wait, how does assert work? Go to definition. You go to definition on assert. You read the doc comment, which I guess, well, if you have an LSP, you can also get this information from the LSP, for example. But you can also read the implementation, and you should take a look at the implementation of things. And I guess my point is that go to definition is literally the fastest way of getting access to this information. It's faster than tabbing out and searching in the docs. Just go to definition. Get used to it. It's a superpower. Yeah, actually, I feel claustrophobic when I'm in a language where I cannot do go to definition. Like I really start feel like I'm missing oxygen because this is amazing. Point number 2, do practice stuff. So don't only read, but also type out code. You need to type out some code. The more Zig you bang out, the more you learn. And third and last thing is join a community, interact with other people, so that they can unblock you if you get stuck, if you don't know how to do something, if you find something confusing. It is perfectly normal to find something confusing as you're learning stuff. And it is fair to say that Zig doesn't have yet perfect documentation for exactly everything, but all of it is absolutely learnable. And if you get stuck, just ask somebody that has gone through that process before you. Related to this, there's Zig days. So look at this. I don't know, people that have been here for like not even that long, like a few months. You might remember back when this website didn't have almost any Zig day in it. I think it had only one in Milan. And then I think it started with the only one in Milan. That was the only Zig day available on the entire website. And look at it now. Look at how many we have. And actually, I have to publish one still. So joining a Zig day is actually a pretty good excuse to learn some Zig. So do consider joining one. Let's see. I'm an old-timer from an aerospace embedded systems background. Okay. Really loving this new environment that can replace C code part by part. Awesome. Well, then never mind. You're coming at it from a very particular angle. That's cool. Then if I had to think of advice specific to what I think might be your experience is, what would it be? I guess one thing would be that I'm not an expert C programmer. I've done a little bit of C in university. I've done a little bit of C back when I was involved with Redis. The impression that I have when I see C projects is that they tend to have in them some idioms that are not really designed to be optimal. They are designed to just survive limitations of the C language or quirks about it. For example, sometimes things that could be an assignment, they become a mem set because otherwise it would be UB in C, and that's weird to read. Sometimes I see some also the fact that there's no generics, so a lot of type safety goes out the window and stuff just becomes a void star pointer, and that's it. sometimes I see that people create tiny buffers on the stack to parse something, for example, like to parse a short string, but then the size of that buffer is completely arbitrary, and it's weird. You can do better with Zig. For all these things, you generally can do better with Zig. Now, that said, I understand that some things are known for performance, some funky pointer math maybe is genuinely the best way of doing this. Although, by the way, you can do some pointer math in Zig as well. So don't know that for example, if you have a pointer to an element in an array, in a list of elements, and you subtract the base pointer of that array, you will get the index where that item is in. So that works. But in general, we work with slices more. Oh, here's a key one. Here's a very important one. Man, I was looking at assert. Okay, so this is actually, you know what? I was trying to think of something useful to say, but this is generally it. This is probably the most useful thing I can tell you. And anybody who has done C, assert in Zig is not assert in C. It is insanely better compared to what it is in C. So here's how it works. Assert is a function that when you are creating a debug or a release safe build of your program, if your assert turns out to be false, then you get a crash because the assert turns into a panic. And maybe I should say, I guess, take one step back. Why would you use assert? Assert is what you use to write down in the code invariants that should be, well, invariants, preconditions, postconditions. So basically, you assume a function assumes that a certain thing is true for the thing that it's doing to make sense, and so you can assert it. So for example, here, let's see. Let me see if I can find a better example than this. Let's look at the schema stuff where I put some nice asserts. Go to references. I'm trying to find like a good assert that I like. Let's see. Okay, we're in some code where we're looping over AST nodes, and we are in a struct union node, and we're trying to get the first child of the struct union, but for some reason, we assume that this child has to be there, because for us, 0 is a... Oh, I mean schema, that's why this stuff sucks. Never mind, let me take a look at the schema AST, because I think this might be better. Yeah, look at how many more asserts I put in my new code. So this one is nice because it talks about all the things that I mentioned. So this is a thing that, given a pointer to a node and the list of nodes, it tells you what the index of its first child is. And to do that, it first computes the index of the node that you provide into the array. And it does that by subtracting the base pointer from the node pointer. And because these pointers are typed, then you automatically get division by size of node. So that means that then you get here a proper index. But also, I'm adding assertions, and I'm saying, wait, okay, so for this to work, the pointer to node needs to be a bigger number than the pointer to than the base pointer, because otherwise you're passing me a sus pointer. This can happen because you could have made a copy of the node and then you're passing down a pointer to your copy, which basically breaks this whole logic. And so I'm asserting that that your pointer leaves past the end, past the beginning of this array. And then when we compute a number, I'm also asserting that this value is within the length of this array. So these are obvious things that have to be true for this code to make sense. Assertions, as I was saying, in release safe and debug modes will turn into a panic. So if your invariants, preconditions, postconditions are falsified, then you get a nice crash, which is good for testing. It's good for debugging. And in case that your software runs in your software is running critical stuff, then and a crash is a desirable behavior rather than other types of misbehavior, then you want that to be turned on. But if you're making something like a game, or like you're making something where you're aiming for achieving a bug-free version of your software, right? Because any software will start to have some bugs, but then if you don't touch it and you just apply bug fixes over the years, then eventually you will have iron out all the bugs. So if you're aiming for this stuff, what you do is you can make a release fast build, and in a release fast, assertions become hints to the compiler on how to make optimizations. They become impossibilities. And this is woven very nicely into the type system because, for example, you can have a switch where one of the cases is unreachable, and unreachable is the keyword that you see how assert is defined as a function of unreachable is saying if it's unreachable for okay to be false, and that's the assertion failure. So basically that helps creating more optimized executables. One important thing is this: in C, assert is a macro. So what happens is that it's that usually, I believe, as a macro, it normally either is there and stays as a panic, or it's completely taken out, as in the entire line is removed, like the entire invocation of assert is removed. That's not the case in Zig. In Zig, the invocation remains, but then it becomes a no-op, or rather, it doesn't become a panic, it becomes an unreachable, and so some of the logic can be simplified, but if what you put in as arguments to your assert has side effects, that will still be run. So don't think of Zig asserts as C asserts. I guess it took me a long time just to say this. Don't think that Zig asserts are C asserts. They're absolutely not. We don't have macros in Zig. So if you put a side effect, if you have like an expensive thing with side effects that you put as an argument to assert, this will still be executed even in release fast. Because while the assert becomes an unreachable, if this thing here has a side effect, then it will be still run nevertheless. So sometimes you will want to also to distinguish between asserts that you want to run only in debug builds versus asserts that you want to run whenever safety is on, which also includes release safe. Anyway, so what were we doing? We were enough Zig. Let's do some JavaScript. So we were looking at this. We changed how enums work. Line string, quoted string, identifier, string content, number. Okay, so this number and string part, I believe I copied from a JSON implementation because we want to have JSON style strings. Okay, let's see if we can build our histogrammars and be happy. Visitor generate. No, we're not happy. Undefined symbol dict. Okay, right. There's a map thing that I forgot to rename to dict. So this is now dict field. This is dict. Okay. We also need to update the SCM files. Dict. Okay. This seems fine. Do we build now? No, we don't. Undefined symbol map field. Okay, so dig field. Okay, now we generated everything. Let's take a look. Okay, the LSP isn't happy. That's fine. But you see how everything lost color? It's because we got a parsing error in our highlighting queries. And unfortunately, we don't know what it is. Unfortunately, we do not know what it is. We can discover it though. I'll just want to take a, I guess, a quick look first myself. Usually when stuff like this happens, it's in here. So let's do a quick pass through. Force, null, number, struct field, enum. It's a function. String, line string, comment, escape sequence, error, comma. These guys, stop comment. Okay, so far so good. So how do we debug this more? Well, we need to take a look at Helix logs. And Helix is not great at telling us what's wrong, but it does say something about this. Oh, right. Right. We need also to recompile stuff here. I forgot. Okay, there we go. Okay, so never mind. I just needed to recompile. So we're happy. Kinda. I think that these dots are not currently accounted for. I think they are bold. Hard to say because it's just a dot, but I think they're shown bold. Actually, we can do this. I like name error. So Tricitter sees this as an error node. So we need to account for those dots, I guess. Do we want dots in front of structs? Maybe we don't. Maybe we do not. Maybe it's fine. Maybe it's fine and we'll leave it as is for now. Okay. Let's make the syntax highlighting a little bit better. You could go for a superset of both Zon and JSON. Yeah, I thought about this. I think some of it, it's kind of, we can approximate that, but we cannot do that fully precisely. Zon has one issue. In Zon, there is no list syntax. There's no list literal. So in Zon, the list above would be this. It would be a list in curlies. So we could support that as a, non-preferable syntax, like it's supported, but then the autoformatter always turns it into square brackets. We could do that. Yeah. But that leaves, so this is, in any case, this is one problem. And then there's the second problem, which is that string escapes are incompatible between JSON and Zon. So we could say that we support one style of string escape in maps and a different one outside of maps. That would start making Ziggy kind of an insane format, though, where you have two different types of string escapes. Yeah. I would say that for now, I wouldn't worry too much. That sounds like a fun time. Yeah. Okay, let's make these things a little bit better because I think that I'm saying that too many things are not what they are. So true and false, they're Boolean. Null, it's a constant built-in. Number, it's a constant numeric. Yes. Struct field. I'm saying that it's a keyword, but it shouldn't be a keyword. I think this should be just a field. Actually, is field a thing? Yeah, field is a thing. So this is a field, and then an enum is a function. Is an enum a function? What do we do in Zig for this? Constant. Do we do that also on usage? constant. Okay. So maybe we could do this, I guess. These guys are strings. These are comments. Punctuation delimiter. Punctuation bracket. We should probably also have equal sign and colon as punctuation. I think this is it. So this is what it looks like. Honestly, not super exciting, but This week we started writing some simple code to see what workflow develops. I'm wondering if I should start with Helix for two-seater and perhaps some nice debugger features. I'm not sure yet. You will be able to have, I don't know what you use normally, but you will be able to have a very good experience in most mainline editors. So VS Code, of course, there's an official Zig extension that also helps you set up both Zig and ZLS. It's, I think, particularly nice on Windows because Windows is otherwise a mess. Although I personally like to manage those things myself and not have an extension do that for me. But, you know, I guess it depends on how deep you want to go into the rabbit hole. Helix, of course, works well. If you're a NeoVim user, NeoVim also works perfectly. If you're using, I don't know, Emacs, that part I don't know because I don't know how well language servers do on Emacs. I think it's more complicated. I think there is support for that. But I have yet to see somebody make that work on Emacs. Maybe it's just me not knowing anybody who has a good setup in that sense. I only know Johnny Marler who uses Emacs and he never bothers setting that stuff up. Vim plugins in VS Code. Okay. So yeah, the only mild question mark would be Emacs in my mind. That's it. So yeah, I personally like Helix, but you know, I would say that if you're used to Vim, just stick with Vim. Helix is basically Vim for people that are too peanut brained to actually learn how to use Vim, like me. It's just that I don't feel like customizing stuff, and Helix gives you a decent experience out of the box. So that has been the main reason why I got into it in the beginning, and then I got used to the keybinds, and so now I live here. Anyway, so we're happy. I think we're happy now with the changes to the three-seater grammar. I think nothing else is needed for now. I do wonder if this should be made different than this. Also, there's a question of whether we should allow this syntax. That would be curious, but I think that even though it's redundant, these parentheses are good. They help give structure. I want to keep them. Okay. Oh, you watch that stuff? Nice. Yeah. He has a more recent interview with. He recorded like a few days ago an interview with a famous guy, Scott Henselman, I think. I just wasn't sure how to pronounce his surname, but he has this. Yeah, no worries. I do these things to chat with people. What do you mean? No, don't be silent. Mark send. So this is this. I'm gonna send it also on YouTube. So this is the interview that Johnny made recently with Scott, who I think he's a pretty famous Microsoft guy. So I don't think he needs introductions. Okay. Oh no, I did not want to do this. No, please forgive me, Lord, for I have sinned. Oh no. Well, it was nice meeting you. Okay. We need to look at the parser and the tokenizer, and I want to remake this stuff from scratch. So this is going to be an adventure, so strap in. So I have the old tokenizer, which I renamed to tokenizer old, and we're making a new one. Okay, index U32. We can take a look at what I did with the schema tokenizer, because I think we can steal some ideas. Also, there's this Lexeme thing, which I'm not even using. Man. You know what? I'm going to delete this. Oh, it could be useful, though, eventually in the future. You know what? I'll leave it there. Fine. Okay, I'm going to copy everything. Fuck it. Okay, tokenizer is this import standard library. It only has one field. A token has a tag and a location. These tags are going to be different now. This one we don't care about. Lexemes are going to be different. Okay, we can copy also some stuff from the old tokenizer. I mean, not everything needs to be done anew. For example, this stuff I think is fair. Let's see. Invalid token, yes. A dot. What's a dot token doing in here? Oh, this is interesting. We had a dot token because I guess we were doing dot and then identifier, but in reality, that made sense maybe in the past, but now it doesn't make sense anymore because now every identifier is prefixed with a dot, so we don't have a dot token anymore. Like basically, it's gonna be an identifier is prefixed with a dot, so no more dots. Comma, yeah. Equal, yeah. Colon, yes. At, no, not anymore. Left parenthesis, right parenthesis, left bracket, left square bracket, right square bracket. Yes, these guys do exist. Hi, what is the purpose of writing a JSON alternative? Tariq, the long story short is I've written code for parsing JSON documents in the past. And one thing that has driven me nuts is the fact that JSON doesn't have explicit syntax for unions. And so every time you make a union, you have to kind of fake it. And everybody does it in a different way and always sucks. So for example, sometimes you see people do this. Let's say that you have a command, a payload. The idea is that your document is a thing called payload, and it can be either a command or a notification. So people do this. They say command, and then there's the command object. So that's one way of doing it. I would say this is the better way of doing it, although you lose one indentation level for this, and which is visually annoying if you have to look at the thing, and also you don't know by looking at this, you don't know if this is a union or if this is a struct with just one field. And then you know that somebody comes in later and says, you know what, I'm going to change the protocol and like the schema, and you know what, we're going to add a second field. And they're going to add something else, like something like ID. And now this used to be a thing that you could consider a union, but now there's also this field. So then you have the problem where you don't know, you know that you are expecting either a command or a notification field, like one of the two in mutual exclusion. But now you see ID first, so you don't know yet. So you have like to buffer the ID and then hope to get to one of these two guys soon. then there's also this other method where people do this. They do type, right? They have a field that basically tells you this is a command. And so if you see type command, then you know which fields to expect, which are going to be potentially different than the ones in a notification. And then sometimes you have this funny thing where they put type at the very end. So first you have all the other fields, and then you have type at the very end. And that is the kind of stuff it kind of, if you're using a dynamic language like Python or JavaScript, you don't care about what I'm describing because you're in any case going to do, by default, hilariously inefficient things when parsing that JSON, so whatever. But if you're dealing with this stuff and you care about performance and you're using a statically typed language and you care about performance, you will find all this stuff like horribly annoying. So this is one thing. Another thing that annoyed me is JSON schema. JSON schema is unreadable. Like JSON already is not the greatest at readability, but JSON schema it's a JSON document that defines a JSON schema, and people make the weirdest shit with that. So if you look at here in my documentation, I have a page where I talk about this. Let's see. I need a moment because I don't remember where I put it. I haven't looked at these docs in a while. Holy cow. Design tips. There we go. Struct unions. Yeah, look, this is an example of a JSON schema. And this thing itself is unreadable. By the way, you see this? You see this? You know what this is? This is a fucking union. This is a union expressed as a type and then case as the value of type. And then they allow you to do everything. Like there's references. There's the fact that sometimes fields can be optional. Sometimes they should follow a pattern. Sometimes they should be part of a list, one of. This is not meant for human consumption. Look at all these regular expressions. Like, what the fuck is this? So this is absolutely, to me, this is unusable. So I'm making my own language that has explicit syntax for unions, that has a schema language that isn't insane. And not only it's not insane, like more readable, but also it's designed to force you to only make sane schemas. Like in this sense, here like basically JSON schema is kind of designed to formalize any possible weird system that you have for your JSON. So for example, you have maybe a struct where 3 fields are always have to be there, and then 3 can be optional, and then the 4th one can be user defined, but it has to match a regular expression. Why are you making a schema this way anyway? So in Ziggy, for example, you cannot mix and match like unions and structs in the same thing. A union, basically, if you want to have a union has to be its own container. And if you want to have a struct is its own container. And if you want to add optional stuff in there, then you stuff it under one field. So this is, in a sense, the biggest advantage of Ziggy schemas. The best feature of Ziggy schemas is that they cannot define every possible data layout. They force you into specific patterns. And it's like, I'm going to say, it's not really too restrictive, but it's not meant to be absurd like JSON schema. When can we add support for this in our HTTP server? Well, it's going to take a moment because I'm still working on it, sorry. But we'll get there. What do you mean by union? Well, if you don't know what a union is, it's kind of complicated. You know how a struct has multiple fields, and so if you want to create a value for that struct, or think of it as an object, you have to fill out all these fields, right? Because a struct has all those fields all at the same time. A union is a container like a struct, but when you define fields in a union, the union will be able to have only one of those fields set at a time. The other ones will not be available. So, but if you're not familiar with the concept, you need to familiarize it with it yourself. I'm not going to be able to do that for you on stream. Anyway, integer, float, null, true, false, top comment line, comment, EOF, sure, front matter. But use elsewhere. This thing's, I find that part sus, so I'm gonna delete it and we'll see what happens. Okay. So next. I'm surprised that there is no front matter like seam here. What the heck? Is there no else case? What happened here? What happened to LSP? What do you mean? So location, selection, get selection. This is all well and good. State, start identifier. Okay, so now we are looking at the parsing code, and obviously this is from the schema language, and none of it transfers, so we have to start from scratch. So, I'm still working on LSP. I'm about to. I mean, if you're talking about the HTML language server, I reached a satisfying point, so I'm now moving to this project, and then I'll go back to it. Like, it's not complete, but let's say that this season is completed. I know what a union is, but it was not understanding it in the context of JSON. So the issue you're solving is when needing to parse JSON efficiently, the existence of unions and non-standard schemas makes it annoying. I haven't faced this problem. I work mainly in machine learning using Python, so the way we parse JSON is just loading it into an object. Yeah, it is readable. Yes, I think the way in which you start feeling it is when you start writing client code from web APIs that use JSON as their communication protocol, and then as their communication data format, and then you will start feeling the pain, especially if the API is not well designed. For example, when I made Bork uses receive JSON over WebSocket, and it's bad. It is bad because there's a lot of cases that you have to account for, messages, user information, donations, subscriptions, Prime subscriptions, emojis, and all this stuff is wonky and annoying. And also it's versioned, so depending on, different versions of the same API. So it's kind of crazy. In any case, so here's another reason. So, but for example, if you've never had to read a JSON schema, then you don't know the pain of having to deal with JSON schemas. And this is what I'm trying to solve here. Here's another one, tooling supremacy. I find it super annoying that JSON doesn't have real tooling for it. Like there is, for example, JQ to query JSON, but it's not part of any standardized tool. So I want basically to make a Ziggy CLI and the Ziggy CLI should provide you with formatting, querying, so like JQ but for Ziggy, schema checking to validate a document against a schema, format conversion, and a language server. Most of this stuff, some of this stuff is implemented, most of it it's not. Now I'm making changes, so guess what? I'm about to regress everything. But this is the idea. What would you mean by JSON alternative? Won't you just want structured data and communicate that? What would you call... Wait. What? What would you call structured data? Like, okay, how can we agree on one way of structuring this data. Would you not say that JSON is one way of agreeing on what JSON data is? It reminds me of Metadesk. Oh my god, Metadesk. No, this is a way less ambitious project. This is just a data serialization language that has a little bit more syntax than JSON so that it's easier to understand. And it has a schema language that is easier to understand than JSON schema, and that it is more restrictive so that you're not going to be able to put into a schema your weirdo mix of optional fields, regular expressions, and other like weird things that people do with JSON schema. That's mainly it. This is mainly it. And this all started because when I was making my static site generator, I needed a language to put in the front matter, and I did not want to put, I did not want to use JSON, and I did not want to use YAML, and so I made my own thingy. Somewhere in here there should be, I think, a section about the front matter, or maybe I got it wrong. What the heck? Front matter, there we go. Oh, it just shows the schema. Okay, never mind. Oh, I guess we want to go... I think I know where we want to go. We want to go in site structure, I think. Yeah, basically. Oh, here's another feature that I added to Ziggy. When your top level element is a struct, you can omit curlies and you can reclaim one level of indentation. So the outer layer here is a struct. But because it's the top value, it's the top element, then the curlies can be omitted, and so that makes it nicer, I think, as a language for configuration and front matters. That's it. Ignore the add stuff. I'm taking that out for now. So this is the idea. Okay, so what is the state of our tokenizer? Let's take a look at what the old tokenizer had as state. Start, identifier, number, string, line, string, start, line, string, comment, start, comment, front matter. Well, let's see. Maybe we are gonna need all these bad boys again. Okay, let's see what we had in here. So, next, yeah, null terminated string to tag EOF, location start -1. This is counting new lines. Why were we counting new lines? I guess it was. I guess it's a feature that we probably want to maintain because it was probably beneficial for us. Okay, let's do the simple stuff. Let's port it over. Okay. Actually, we might need this debug print. So we see in null, we immediately do this. What do we break? Do we really have a break? Oh, this is the old one, right? No, we don't break anymore. We return right away when it's time to return. So return talk. Okay, we see null. Then we want to return an EOF. We see a space, a new line, a return, and a T. And then we do if C is N, we do this side effect. Okay, let's do this. Oops. I think we're also missing one level, right? Start. There we go. Okay, we're in the start state. We're switching on the current character. I think we want to have a dedicated case for new line at this point. So there we go. If it's this, there you go. If it's a space, a carriage return, or a tab, let's swap these two, tab, carriage return. Then we just skip the white space. Ziggy doesn't break by default. No, this break, this is code that I copied from this other code. And here the switch is inside of a while loop. So we were breaking out of the while loop. The switch doesn't fall through. This break is not for the switch. This break is for the while. So now that the while doesn't exist anymore because I'm using labeled switches, this break, it just doesn't mean anything at this point. But we need to increase the index. So in all these cases, t dot in idx plus equals 1. Actually, that's the one case where we don't do that. And I think we're on this last. Okay. Okay, so here's the interesting thing. We see a dot. Previously, a dot was making us emit a dot token, but we don't do that anymore. They're not a thing anymore. So this should move us into the identifier case. So dot should do, should make us consume. Actually, should it make us consume? I think so. And then it should make us do continue state with dot identifier. This should move us to the identifier case, which also means that this guy probably should be moved down, just so we have the trivial stuff up front. Comma, t.edx plus 1, tag is comma, and is idx. Oh, never mind. Then we do put this first. Okay. And then we return this. Return talk. There we go. Also, no, this is fine. Okay, equal sign. t.idx plus 1 equal. No. Okay, I also modify the function. Okay, so we're saying equal sign, increase, set equal sign, set end, return talk. Colon, same thing. At sign doesn't exist anymore. Open parentheses. Yeah, left parentheses, that's fine. I haven't checked the compiler upload to see if there is a difference between returning versus breaking on the tag with a label switch. I should imagine there is any difference. The reason why I'm doing so in general, so setting aside this specific concept, but in general, a label switch versus a while loop with a switch inside the label switch wins hands down. Like my previous tokenizers that I moved to the new system have gained like 50% speed, each and every one of them, more or less. The return thing by itself is not something that improves performance, I think. But let me tell you why I'm doing this. I'm doing this because in the past, I've had bugs where basically I would, by mistake, fall through. So by mistake, I would have a case that would make me, the control would flow out of a specific case and go past the switch. And I don't want to do that anymore. I found that it's much easier, for me at least. I'm not saying this is necessarily like a universal truth, but for me, in my tokenizers, I find them much easier to understand if there is no fall through from the switch. So you either keep looping in the switch or you explicitly return from it, as in like proper return from the function. And to enforce this, I put comp time unreachable afterwards. So this comp time unreachable makes it a compile error if I have an accidental fall through. Specifically, I had at some point a case where I had something like this. I had a case that had like if condition, and then it would do stuff. And I didn't notice immediately that there was no else case. And so then if the condition was false, it would fall off the switch. And so I'm doing comp time unreachable now to ensure that that does not happen. Does Zig do the other approach where you do label control flow instead of goto? Or does it do both? Zig does not have goto. The only thing that has... you can continue and you can break to labels, but it's nowhere near the things that you can do with goto. Like you can have a block. You can have a block, you give it a label, and then in the block you can do break BLK. Either break BLK just to exit early from the block, or if your block is has to produce a value, then you can then you can break with the value that you computed. This idiom is nice when a variable initialization is a bit complicated, and so you scope it into a block, and then you break with the produced value. So this is the general stuff. Then you can give labels to while loops. So you can do outer and then while condition. And then in there, maybe you have another for loop. And so in the for, you can either break from the for loop or you can break outer. So you can break the outer loop. Then the last thing is that switches have recently gained labels. They didn't have those in the past. And a label basically allows you to do this. So here, for example, I'm seeing a dot and I want to continue the label state with the value identifier. So the way this works is that I'm going back up here and I'm switching again, but not anymore on the value here in parentheses, but I'm switching on the provided value, the one that I've hard-coded here. This is what allows you to express Duff's machines. If you don't know what those are, Duff's device, sorry. No, my eyes. Wikipedia, what are you doing? Oh, okay. Oof. So, Duff's device is basically, it's an optimized way of generating code for a switch that is better than what you get by having a switch nested inside of a while loop. So the whole reason why switches have labels is to create stuff like Duff's devices, which is why tokenizers become faster when you switch them to this new approach. But that's it. Okay, so this part is all easy. So all the simple stuff we've dealt with. Now we're missing numbers and identifiers. And well, I guess booleans as well. So let's see what we had here and let's copy it over. Oh, does it say dash? Oh, for the front matter. which moves us to the state front matter. Sorry, what was the state front matter doing for us? Oh, I guess because we were accepting also the one at the beginning. So we are in the state front matter. We skip white space and on a new line or an EOF, we return the front matter token. This logic is really weird. I was doing some funky stuff with this tokenizer, man. Really funky stuff. Let's do the simple stuff first, and then we'll see about the rest. Okay, so we certainly want this stuff here. So 0.9, we don't want to consume. I guess we can basically turn it into the new version of the same syntax. So, you know what? Also, state identifier. We also need to mutate some kind of state variable. We weren't doing this previously, so I guess we don't have to. Okay, 0.9 means continue state number. Continue state string. Although for string we probably want to consume, but we don't know. We'll see. Continue state list string. Continue state comment start. Otherwise, tidx +1. Okay. And by the way, you know what? We can race the old tokenizer with the new tokenizer after I'm done with this to see how it goes. So this tends to make sense to me. I'm not sure if I should consume or not, because here I'm consuming for the dot. Guess we'll see. In any case, we're now, let's do the identifier case. So identifier state. So we switch on source at IDX. And then, so an identifier, basically what I want to say is that, I guess I have it on the other side, right? Normal letters are fine. Else finish identifier and then break. Also, notice how the old tokenizer didn't have explicit advancement of the index, which now that I see this, I find it problematic, because here it's very easy to reason about whether we're consuming or not. Here it's implicit. I don't know. It kind of sucks. I mean, in any case, so okay, this is what we allow as an identifier. That sounds good to me. So then what do we do after that? Well, basically we advance, we consume. Then I think we should deal with EOF. we're basically, I guess on EOF, we don't consume the EOF, and we return the identifier. I don't know why I had a finish identifier. I guess it was, why was I doing this? I don't get it. Well, I don't get my old self. In any case, we advance the IDX and then we continue. We continue state.identifier. Then here on null, we do t dot talk dot tag equals dot identifier. Lock end is t dot idx, and then we return talk. We don't advance because we're at the EOF already. Funky UTF-8 stuff? No, I don't think so. Okay, so this is it. If we see something else, actually, you know what? This, we do the same also for else. We don't consume the token that we don't recognize. So we just consider that the identifier ends there, and that's it. So this is it. This is our code for the identifier. This is correct. Okay, next is number string. So we need to do number string, line string start, and comment start. So let's go do that, I guess. Number. Oh, and also here's what we need to do. We need to change some of the string syntax because of escapes that I think in the original code we are doing Zig style escapes, but now we need to change those into JSON style escapes, and that's gonna be bad. In any case, number. I'm gonna switch on C, we switch on source at t.idx. If we see 09 dots underscores, oh, you know what? I think I know what finalized identifier is. I think what that thing was doing is complain. Actually, you know what? I have no idea. Who cares? Okay, if we see 09s, dots, underscores, minus, pluses, e's, lowercase e, uppercase e, I guess we can zoom and continue. Plus equals 1, and then continue state number. Otherwise, you know what? Let's take a look at this implementation. Okay, what's finish identifier? Oh, it recognizes true, false, and null. That's what it was doing. Because those are like, they look like identifiers, but they are special. So we were basically just recognizing those. Let's call them like keyboards. That's what we were doing. Well, that's different because our identifiers are all dot prefixed, so we don't need to do this anymore. What about finish number? What does this one do? Oh, it does Zig style parse, literal number parsing to decide if it's a valid number or not. This is kind of a hack. Yeah, I see. But I guess we could keep it. Yeah, to be honest, I'm not super convinced that this is the right way of going at it, but that's what I was doing before, and I don't have a better approach now. So I just repeat what I was doing. Yeah. Implement this natively. Yeah. Minus minus. Why was this called minus minus? I don't know. I don't know. Okay. Well, let's keep this like this for now. That's fine. Okay, so we have identifiers, we have numbers, we're missing strings, line strings, and comments. 3 things. Strings are going to be super annoying. I'm tempted to keep the bad implementation for these things, I think. Oh, wait, there's going to be states for these things, huh? String, line string start, line string, comment start, comment front matter. Okay, so this is the old string code. If we see an EOF or a new line, oh man, look at this. But we can do better now. We can do this. Can we not fold through? I think we can fold through. Like this. Although, you know what? Who cares about this? We can just do this. We also need to increment here because otherwise we're going to double count this new line and we don't want to. So let's do this. If we see an EOF, we do not increment. We set this to invalid. And then we return it. To be honest, these two are like different enough. I expected them to be more closely related, but they're not. Okay, so yeah. By the way, this is the one I was talking about. This is the one that I originally did forget that it had an else case because it looked like this, and so I did not even, which is like kind of a weirdo expression, and so I didn't notice that it was missing an else case and was causing a fold through that I wasn't accounting for. So so this is the case where we are seeing this. Okay, else t.idx plus equals 1. Also take out this label because we don't need it. Continue. Okay. If the current character is the same character that started the string, basically we found a matching quote, be it a double quote or a single quote, because we're supporting both. Which I don't know if we should. But in any case, we're doing it for now. I guess we should because, wait. Wait a second. JSON does not support single quote strings, does it? I think in JSON, it has to be double quote, doesn't it? Now, what is it? Oh my God, no. There's a double quote, but there's no single quote. Haha. Then why do we even care about the single quote? Why do we allow single quotes? You know what? No single quotes. No single quotes. So if we see a double quote, if there's an even number of slashes before it, which I believe is the case where we want to exit. So I guess we can do, if not even slashes, then we continue. Do we do an early exit? Yeah, let's do an early exit. So t.idx plus equals 1. Although we want to do that unconditionally, I think. So unconditionally want to increase. If it's not even slashes, we want to continue state string. Otherwise, token tag is string. Oh, snap. Even slashes. We cannot increment before doing the checks. So, I guess we need to slice before. We have to do this before we increment. Okay, let's copy over even slashes. Okay, so there we go. If we see in a string any other character that isn't one of those guys, for now we're not doing anything else. Should the slash before IDX be the only one that you need to verify? Well, people also, there's this case though, where you have a string and you're escaping a slash. So if you escape a slash, this is actually a single slash that's being escaped. It's not a slash that's attempting to escape this quote here. So in any case, yeah, this is not the greatest code. I agree. Like proper string validation would have proper escape validation, right? It would check that for example, the escape sequence is valid. And I'm not doing that. So we would probably need to have a bunch of string dedicated states for proper escape checking. I just didn't implement them the last time because I was, prototyping stuff and I was still trying to wrap my head around whether I wanted to do Zig style escapes, JSON style escapes, something different. And at the time I settled with doing basically Zig style stuff in general, but now I want to switch to JSON style. So yeah, this probably should be expanded into string escape, and then we look at the individual escapes case by case, and we don't do this even slashes. Kind of a hack. If you want to return a value from the else branch of an if statement, but the branch is a block, do you really need to use a label? Yes, you do. Or don't make it a block. If your if doesn't have blocks in its branches, then that's the value the if results into. So you can do this. This works. This is correct. But if you put a block in here, then a block evaluates to the void value by default. So you need to give it a BLK, and then you need to do break BLK with this value. But the idea is that if you're doing this is because there's more stuff going on in here, right? You need the block, you have a bunch of statements, and then you want to break at the end. In any case, I agree. This is kind of ass. But you know what? I kind of want to port the whole thing to this new system, and then I think we can do this improvement afterwards. Like we can look at number and string and be more critical about how they're implemented and implement them correctly. And I think that we have something that can help us, specifically the JSON parser in the standard library, because that one is spec compliant to JSON, and so we can do that. Oh yeah, blocks evaluate to the void value, and also that's a thing that you can even leverage. So for example, if you make something like this set and you make it a I don't know, like string hash map. So it's a hash map that has string keys, and then it can have values. The value that the hash map holds for each string key can be decided by you, and you can put void. And if you make a hash map that has void values, you just made a set. Or you made a specific variant of a set. There might be, depending on what you want to do with this set, there might be better approaches than just using a hash map as a set. But this works in plenty of cases. But here's how it works then. If your values are void, then how does insert work? So the way it works is that you do set equals set type set. Let's make it unmanaged. Equals empty. So I created an empty set, and then I do try set dot. I think it's put. Yeah, put wants an allocator. Let's assume that there's one. I'm making this up. I don't have an allocator in here, but let's imagine that we have one. Then it wants the key. I don't know, banana, and then it wants the value. But the value is void. So how do you do it? You put empty curly braces, because an empty block evaluates to the void value. And so that's how you put void. That's how you do a set hash map. Okay. So let's cover more ground. In any case, yeah, I totally acknowledge that this is simplistic. We'll make it better. Let's finish porting first, though. Align string. So align string is actually nicer because it's less complicated than a string, because it doesn't support escapes whatsoever. If we see a slash, we continue, but we're also advancing. If we see something that isn't a slash, we say invalid. Oh, because this is line string start. To be fair, I guess this is the conundrum of whether you should express every single comparison as a case in your switch versus you should put more logic or not into a specific case. Honestly, I don't know what the right answer is to this. But okay. So basically, we saw the first slash, then we're searching for a second slash, and if we find it, then we know that we are inside of a line string. Otherwise, we don't think we are. Okay. Line string then. Oops. Okay. Line string source t.idx. If we see in a line string a new line or a EOF, then that's where the line ends. Yeah. But these two cases have to be separated. They can't be the same case anymore. So let's do null first. In a null case, so this definitely does not happen. This definitely is not necessary. So we say that the line string ends here and we return it. That sounds good. New line. We increase the new line count. We said that the line string ends here. We increase index and then we return talk. Okay, so this looks right to me. Else case, we advance. What do you not like about what I'm doing? Continue. Okay. So this is line string. Now we have comment start, comment, and front matter, I guess. Let's copy comment start and comment all at once. And I think this guy needs to be forked. So we find a null in a comment. That could happen, I think. So if we want comments, we call finish comment. Why do we increase? We should not increase when we're on EOF. Oh god. I guess we return token. Otherwise, if we don't want comments, then we go back to the state start. We say that the token starts here. Oh, we're basically delegating everything to that case, but I mean I guess this is just a case where we return EOF. What are we doing? Yeah. So this is how we do the null. Man, this code was so naive. Yeah, it's fine. Finish comment. Increase the new line, move forward, return the token. Otherwise, yeah, now we want to do the state start thing. We go back to start. We are on a new line. I think we should do the new line count unconditionally though. No matter what, we do the new line count. Then if we want comments, we finish here. Otherwise, we go back to, we say that the token starts here. And we continue to the state start. Yeah. And if we see anything else, t.idx plus equals 1, continue. Okay. So comment is good. We're only left with front matter. Maybe we can skip front matter for now. And let's see how it goes. So we have all these tests that we can delete because we don't... oh, you know what? Maybe accept the fuzz test. That one we keep because that one is going to be good. Okay, let's look at the other tests that we had here. Test case. Oh, interesting. Test case. Oh, I see. Okay. Okay. So I ported over all these tests. Do they have testing for the front matter or they do? So those ones will fail. But the others should succeed. Let's try it out. Oh no. There's all the cases where we're expecting dots as a separate entity from the identifier. Oh, whoops. Well, that's not a thing anymore. So, yeah. Well, long story short, these tests need to be updated to the new changes that we made, which is, I guess, reasonable. So, no more dots. No more dots. No more dots. No dots. No dots. Dots. Okay. No, oops. No more dot here. Okay, let's see how we're doing. Definitely fewer errors. That's nice. We're missing, oh yeah, we're not handling the front matter case in here, so that's their complaint. No field name want comments instruct tokenizer. Right. I'm not sure if this is the right approach, but whatever. And I guess false. Okay, we're missing only the front matter stuff, at least for now. So what do we do for front matter? I guess we can put it in here. Actually, do we even do this? What were we doing in the original one? If we saw a dash, so if we saw a dash and then we saw basically a triple dash, then we would move to the state front matter. Otherwise, we would move to the state number. That's that's fine. But why do we have a state for front matter? That part surprises me. If we are in the case front matter and we see white space, we ignore it. We do count new lines. But then if we see anything else, we consider it invalid. Oh no, wait. Okay, I see what we're doing. We're basically saying there can be spaces, there can be white space after the triple dash, but then at some point there has to be a new line for it to properly count as a front matter token. Because to be fair, the dash dash dash, you want it to be on a dedicated line. You don't want it to be yeah, you don't want to have others content on the same line. You don't want to recognize it as a front matter separator in that case. I think that's a fair thing, although just that you need a dedicated state for it, maybe. Maybe. Okay, I get it now. I get the logic. So here's what I'm gonna do. I'm gonna take a very quick restroom break. I want to take that as an opportunity to run the stupid ads from Twitch so that they don't annoy while I'm doing stuff. And maybe make myself some tea. Oh, it's 6 p.m. No tea. No tea for me. But yeah, just very quick break and then we can continue. So the plan is make this work, pass tests, benchmark against the old implementation, and then continue the integration work, because then it's gonna be time to touch the parser. Oh my god, I'm so not looking forward to that. I'll be right back. Okay, I'm back. Do. Okay. So, what are we doing? We missed the front matter keys. Right. Let's copy it over. Do. Okay. So, space, tabs, carriage returns, we skip. So, d.idx plus equals 1. Continue. State front matter. Then new line and null. And I bet you that these guys benefit from being broken up. Okay. New line, increase, move forward, move past it. Actually, do we count the new line as part of the token? I don't think we should. Should we? I think the token shouldn't have the new line in it. I mean, we are kind of considering the new line important, but I don't think it should be part of it. So we do this after. And actually, yeah, you know what? We should. I don't think we should put the end. We don't set the end here at all. And instead, we set the end. Well, in the other case, up above that, I didn't implement. Okay. But if we see something else on the same line, we consider it an error. Yeah. We do the +1 afterwards. Okay. I find this agreeable. Let's do the minus case. Up here. Minus case. State number, but I find this sus. Am I not? Am I setting the start point of my token in here? No, I'm not. Oh my god, was this thing so busted? What the heck? Yeah. Also, I find this so weird. So weird. And we can even consume this number. We don't need to switch on it twice. And I think the case is also for a lot of other things. This code is real sus. Also identifier t dot talk dot lock dot start equals t dot idx. Oh my god. Oh no, wait. We're not doing. Okay, I see. We're not doing the start because we're setting the start in here. Right. Start is set in implicitly. I'm a dum dum, so that's fine. So here we only concern ourselves with setting the end. That's fine. I'm a dum dum. I think this should be +3. Okay. Okay. So we should consume this. I think we should consume the quote as well. And I think we should do the same also in these other cases. I think that the original code was doing it just implicitly. Okay. How are we doing now? We don't have finished comment. Yeah, sure. Let's see. What does it say? Oh, if it starts with an exclamation mark as the top comment line. Fine. Reached unreachable code. Oh no. No field name tag instruct tokenizer. No field name tag instruct tokenizer. Okay, we have the problem that we're reaching unreachable code. Why? So this, we're basically missing either a return or a continue here. There we go. So white space. There we go. Okay, there's more. New line. Continue. Continue, return, continue, return, continue, return, return, continue, return. I think we might be good. There we go. Now we're failing our test. What's going on? Expected false, found invalid, bad token, invalid F. Right. We're missing finding those thingies. So we kind of want this. I think instead of identifier, we're going to call it like built-in or keyword. So the way it works is that if we see this at the top level, although we do it only with letters, we do that. The problem, so the reason why I'm doing it this way is because I want to not only complain about them, like I don't want to have every single character be an invalid token. I want them to all be collected into one invalid token. So we do this. We don't have numbers. We don't cover numbers there. So we say, in this case, 2+1, state built-in. Built-in keeps collecting those, including numbers. Sure. And then we say, okay, now that we're at the end, let's see. We put an end there. We say that it's invalid. Well, we don't have to do this. We put it in there so that we can slice on it. There we go. Bad token, invalid, no valid, failed at index 1. Expected identifier found invalid. Okay, what's the test? Invalid comments. Oh, well, shit. Invalid and then identifier. I think we should restart this tokenizer a little bit and say something like this instead, I think. Instead of built-in, let's change this to invalid. So there's like an invalid trap state where we basically keep collecting anything that isn't white space. And we collect it into white space or like symbols, like letters. We collect them into one thing. And then this is it. This is just one invalid token. And that's it. And then up here, if we see a letter, we immediately do the checking in here. Hey, the one who has walnuts. Hello, hello. Yeah, I would say that up here we check right away Although we don't know, Windows starts with. It's not enough though. Fuck. You know what? I think we need the built-in case. We do need the built-in case, but then okay, let me do it this way. I'm gonna copy this. I'm gonna restore it to what it was before. The question though is, okay, we see comment, we go to comment start. If we don't see this, we immediately go to this invalid. Well, instead we should go to an invalid state. So, okay, let's go to the invalid state. And we say it's invalid, the whole line is invalid, or until white space. I think until white space we say that it's invalid. Or where like something isn't letters. I think that works for me. So here basically we do else, consume it, and then go to the invalid state. Yeah. And I think they can do the same also in other cases. For example, line string start, we don't do this, we do this. And I think that was late. Still, I think this is preferable. Okay, let's see if this passes the test or not. If it doesn't, it like fine, doesn't matter. We adapt the test. Okay, expected dot identifier found dot equal. Bet token equal in invalid comments. Okay, what happened? Invalid. So the top one should be just invalid. This one is identifier equal sign string, comma, let's see. Identifier found in invalid string. Okay, so that test is fine now. So we have the invalid string. Oh, oh no, what a mess. Left square bracket, string. This cannot be an identifier. This is invalid. Followed by another invalid token. I think it's fine to keep those as two separate invalid tokens. UF false. Okay. Holy shit, we're happy now. We pass all tests. I don't have a ton of tests, but the basic stuff is there. Okay. So the tokenizer is written. I think I'm going to maybe, I don't know, we can try to benchmark this a little bit. And then I think I'm going to call it a day. I don't have the energy right now to start the parser work. There's just no way. Also, I did a parser work for Ziggy schema on my own, not on stream, and I think it was a good move. So I think I will replay it. I will also do it again in this case. I like the minimalism in Zig, impressive, which with Zig's own standard library hash map implementations, or even the crypto stuff. Oh yeah, well for the crypto stuff, you can thank the creator of libsodium, Frank Denis, because he has contributed most of this stuff. So like he's a very famous crypto guy, and he just did the work. He also did some. Oh yeah, you already mentioned validated implementations. Yep. Okay. Yeah, let's just quickly benchmark. This is just for funsies, and then we call it a day. So let's see. I don't know. Test.zig, I guess. Pub function main. Or 0 dot dot. I don't know. A lot of times. We need a test case. Let's extract it at the top level. I don't know, something like this. It's nothing crazy. Just so var t tokenizer equals this was new to us are a real mess. Yeah, you know what? Somebody should make Discord too. Right? I'll get to it. I will get to it. Okay, so here's a for loop, blah, blah, blah. Okay, it's running. Man, maybe I overdid it with the number of iterations. Okay, like one run takes a bit. Maybe, I don't know, give it a 1-0. Well, I guess the way we would do it is this. Okay. Yeah. Okay, so this is one case. So Zig build dash o release fast test dot zig. Let's call it new. Wait, is it not o release fast? Oh my god, what am I missing? Oh, it's Zig build exe. What am I doing? Is it dash dash name? Okay, so having the new one, then here we import tokenizer old, and we create old. Oh god, this one wants the want comments. This was a little bit too fast at building. Why was this so fast at building? I don't know. I guess it builds stuff. Okay, let's do, what is it? Hyperfine. Old. New. Well, I mean, it was kind of clear. New is kind of twice as fast as the old one. And there's a switch an organization from Discord to Zulip without accepting the updated TOS. Huh. Okay. So, I mean, this is not a surprise for me. They should be probably not a surprise to anybody, but yep, turns out that the new Tokenizer is better than the old Tokenizer, significantly so. So, yep, that's one win. To be fair, though, I mean, tokenizing doesn't take much, so the overall impact in all the Ziggy tooling of these changes will be very small, to be clear. But we made it also a little bit better. Not entirely better, though. We still have the shitty number and string parsing code, but, well, tokenizing code. But we can make it, we can improve on it. Okay, so this is it for me. This is it. I'm going to work on the parser, I think, on my own at some point. I still have to do other stuff. So I just indulged in some Tokenizer work today. And I think the plan for Ziggy is going to be the following. We make the Tokenizer better. We make the parser better. If we are good at making the parser better, by the way, the parser for Ziggy was kind of a nightmare the last time. We ended up having to have a dedicated parser for the language server that was different than the parser that you would use on the CLI. And maybe we still want to do it. Maybe it's still an open question. But I think that some of the problem was that I wasn't that good at making parsers then. And now I learn a couple tricks more. Also, label switches do help a lot. So it might be that maybe we won't need to have separate parsers. Maybe we should. Maybe we should, maybe we shouldn't. I actually do not know. In any case, well, the plan is we're going to have better LSP. And then I think that at that point, what I'm going to do is start opening the project for contributions for people that want to contribute, because we need all these, format converters. Although before we get there, we need to re-implement schema validation. I think that the last time we implemented a good chunk of schema validation, but we didn't implement all of it. And the older schemas were simpler. Now we have more complex schemas. So we make this whole thing more robust, I think, this time. And after that, we're going to have a pretty decent Ziggy. Pretty decent Ziggy. Anyway, yeah, this is it for the stream. Sorry, Dev Nina. It's the end for me. It's 6:40 p.m. It's time for me to eat dinner. Also, I don't know. I caught like a seasonal thing. I don't know. I feel like I have COVID or something. So I get super tired and sickly very quickly. So I have to call it a day. So thank you all. See you next time. And I don't know. On the topic of Frank, wasn't this printed by him? It was, yes. I have this one, and I have also another one that glows in the dark. So, oh, and I also have this one. Anyway, thank you all. We'll be busy to a trip to Texas for our week, but I'm going to dig into this language. Awesome. Well, everybody, have a nice day.